Hello everybody. Welcome to Chapter 3, Section 3 on Basic Concepts of Variation. Some definitions to start with. The range of a set of data values is the difference between the maximum data value and the minimum data value within your data set. So the range is very easy to calculate. You're going to take the maximum value that appears in your data set and subtract from it the minimum value that appears in your data set. Something to keep in mind for the range is that it's very sensitive to extremes because it only takes into account the maximum and the minimum values. So as a result of that, it's not as useful as other measures of variation, which is what we're going to continue talking about. The best way to describe variation in a data set is using something called a standard deviation. And standard deviation is denoted by the symbol small s and is a measure of how much data values deviate away from the mean. There are two different formulas for standard deviation. I'm not sure on when this recording posts if this formula will look jumbled on your end. For some reason, as I'm viewing this, it looks a little jumbled, but nonetheless, do go through the slides and look at the formulas that are posted either way. But there's a basic standard deviation equation, which is what you see on this slide. And then there's what we call the shortcut formula. And the major difference between the two different formulas is that the first formula requires that you calculate a mean as it's one of the variables within the equation, and the shortcut equation does not. So some important things to talk about with regard to standard deviations. Standard deviation, again, is a measure of variation of all values within your data set from the mean. The value of a standard deviation is always positive. And the reason for that is if you look at the equations, you'll note that in many places you're squaring and square rooting. And for the final step in both equations, you're taking the square root. And because of that, the standard deviations are never negative. They're always positive numbers. The value of a standard deviation can increase dramatically with the inclusion of one or more outliers. And as we've discussed before, outliers are data values that fall far away from all the other values. So they're kind of anomalies within your data. And because a standard deviation takes into account each data point within your data, they are impacted by outliers. And the units of a standard deviation are the same as the units of the original data values. So if the original units were pounds, then when you go ahead and calculate it out, the standard deviation of that data in pounds would also be in pounds. Okay, so let's do an example. So again, we can use either formula for standard deviation. Either one will get you to the same place. And we are going to find the standard deviation of the number of chocolate chips within 4 cookies. So why would anybody actually want to even study this? So imagine that you're Chips Ahoy and that you make, hundreds of thousands, probably millions of boxes of chocolate chip cookies a year. You want your customer to have a repeatable experience with your product, meaning that if that the cookies look and taste the same and have roughly the same proportions of ingredients between batches. And from a manufacturing perspective, you want to be sure that you're controlling your costs and not putting too many chocolate chips or not enough. So here's our values from 4 chocolate chip cookies. One had 22, one had 22, one had 26, and one had 24. So from this, we're going to calculate a standard deviation. So through the use of our formulas here, and again, it's hard for me to tell on my end whether these formulas look proper on your end, although as I'm viewing this, they do not. So I apologize for that. But if you look at the plain PowerPoint slides without the audio, it'll walk you through all of this. So what you want to do is make sure that at the beginning of each of the equations that you're listing out your variables. So in the first standard deviation equation, you need an x, which are your data values, x bar, which is the mean that you're going to need to calculate prior to starting the equation, and you're also going to need your n, which is the number of data values within. Once you have all of that, you go ahead and plug them in for each of your x's. So to be your x minus your mean squared. And then you go ahead and add everything up. Then you do the same thing for the other side of the equation. And at the end of the equation, where you wind up is the square root of 11 over 3, which is 1.91. And if you were to go ahead and do this with the other equation, you'd get the exact same answer. In fact, you'd wind up at this same exact place at the end of the equation, and so the answer would be the same. Okay, another concept that's important to talk about with respect to variation in data is range rule of thumb for understanding standard deviation. So, range rule of thumb is based on the principle that for most data sets, the vast majority, or approximately 95% of all sample values, lie within 2 standard deviations of the mean. So what that means is that if you were to plot the mean in the center, and you went 1 standard deviation, 2 standard deviations in this direction, and then 1 standard deviation, 2 standard deviations in the other direction, that the span within that would have 95% of your sample values. So let's take a look at this a little further. So what range rule of thumb allows you to do is to take a value that is given to you in a problem and to informally define what usual values look like in your data set, and then in turn to be able to define what unusual data looks like within your data set. So, how do we do this? The equation for this, you want to find first your minimum usual value, which is going to be your mean, minus 2 times your standard deviation. And then for your maximum usual value, it'll be your mean plus 2 times your standard deviation. So, I'm not going to spend a lot of time on range, but if you did have your standard deviation, you could estimate it using dividing your range by 4. But again, this isn't something that we're going to spend a lot of time doing in practice in this course, but it is something that the slides do introduce. So here's an example. So using 40 chocolate chip counts for the Chips Ahoy cookies, the mean is 24 chips and the standard deviation is 2.6 chips. We're going to use the range rule of thumb to find the maximum and minimum usual numbers of chocolate chips. And then based on that, we're going to decide whether a chocolate chip cookie with 30 chocolate chips would be considered unusual. So from this, we're going to calculate our minimum value. So we're going to take our mean, and then for our minimum value, we're going to subtract 2 times our standard deviation. And then we're going to do the opposite to get our maximum value. And so, because once we have our maximum value and our minimum value, then we're able to compare 30, which is the would a cookie be unusual if it had 30 question, and say that because 30 falls above the maximum usual value, we would consider it to be a cookie with an unusually high number of chocolate chips. So a couple of other things to talk about. Comparing variation in data samples, sometimes it's a good practice to compare two sample standard deviations, but you can only do this when the sample means are approximately the same. We're not going to spend any time on population standard deviations, so please just disregard this slide. Last topic that I want to discuss is what we call variance. So variance of a set of values is a measure of variation equal to the square of the standard deviation. So to calculate sample variance, which is what we would be calculating, you're going to take the standard deviation, which we learned how to calculate earlier, and square it. And that gives you variance. So it's a very easy thing to calculate. Just some notation. Please note that the bottom two are for population, so you won't need those. But the top two, S stands for your sample standard deviation, and S squared is your sample variance. Okay, that concludes Chapter 3, Section 3 on basic concepts of variation. Chapter 4 on probability up next.